Today we're going to talk about mass in the metric system, so please have your notebook out and write the title you see on your screen at the top of your page. This will allow you to more easily find these notes when you're looking for them, and we're going to start on the top of page 13. If you do not have space on page 13, then you may start on page 14 of your science notebook. As usual, we're going to highlight the purpose of these notes. Purpose number 1, know the SI unit for measuring mass. Now remember, the SI unit is that official unit we use in science when we're measuring. Is the International System of Units. So that's our first goal. Goal number 2, know how to find the mass of an object using a triple beam balance. And so you'll find that the triple beam balance is a tool that we use when measuring mass, and so your job is to know how to use this tool, or at least a basic understanding, by the time we are done with these notes. Alright, now real quick before I get into this information, I need to have one little change for you guys, and that's to change, instead of saying 2 pounds here, you're just going to have it say 2 pounds. So make sure you're at 1 kilogram or 2 pounds for in your notes. Now, as usual, we are going to look at our English versus our metric units first and identify which is larger. This helps give us an idea of the scale of each of these units, because we're far more used to these English measurements, but we need to make sure we have understanding of those metric units. So you're going to write down which is larger in your notes. Okay, you give that little title, and then you're going to write 1 pound or 100 grams, 1 kilogram or 2 pounds, and 1 ounce or 1,000 milligrams. And you want to leave some space on this side, as we'll be adding some information there in just a moment. All right, we should now have added in our information all on this side, and now we're going to go through. We have these pieces of information revealed, and then we also want to make sure that this has been changed to just 2 pounds. So make sure again that we have made that correction in our notes, otherwise we'll have some incorrect information. So looking at this, we have either the option of 1 pound or 100 grams. The correct answer being 1 pound, as we find that 1 pound is equal to 453.6 grams, which is a huge difference. So 1 pound is going to be far greater than grams, and that's actually why, as we'll talk about later, we don't use grams as our official unit. We use actually the kilogram. All right, so 1 kilogram is going to, or 2 pounds, and kilogram is going to be a little bit bigger. We find that 100 kilograms is going to be 220 pounds. So in reality, 1 kilogram is equivalent to 2.2 pounds about, and that's why I made you change that, as those would actually be the same size. Next, we talk about 1 ounce or 1,000 milligrams, and while 1,000 milligrams sounds like a lot, it actually isn't, where 1 ounce is going to be quite a bit more. Now this, if we have 1 ounce of gold, now it's really important you mention that gold, as that plays an effect as to actually how much. When we talk about density, that'll make a little more sense. 1 ounce of gold is going to be 28,349.5 milligrams. 5 milligrams,
which is
a lot of milligrams, right? Milligrams is a very small measurement, so an ounce is quite a bit larger than that in most scenarios.
Our milligram.
All right, we're going to be on to our next section here on metric units. Make sure you're highlighting the words as in your notes, as well as we want to make sure we're marking those important pieces of information. Now, mass refers to the amount of matter in an object. The base unit of mass in the metric system is the gram. Okay, remember base units, they don't have that prefix. And it's going to be represented by a lowercase g. However, okay, that's important, the SI unit is the kilogram, or kg. Okay, and remember, in the beginning of our notes, one of the purposes was to identify that SI unit. Now, in the previous notes, the base unit has been the SI unit, which is true for all measurements that we're talking about here, except mass, in which that international unit that we use is going to be the kilogram, mostly because it's far more practical for our purposes than a gram. Because as we noticed and made note of on that previous page, a gram is not a huge measurement, right? There's almost 500 of them in that 1 pound. It just isn't as functional. So the kilogram is going to be very functional for a lot of things that we might measure, as it's about 2.2 pounds. And so we're going to be using that kilogram for that SI unit. The standard, so where the actual measurement for a kilogram comes from, is so 1 kilogram is equal to the mass of the International Prototype Kilogram. It's considered the IPK. It's a platinum iridium cylinder kept by the BIPM at Severs, France. Okay, and I know I butchered that pronunciation, but I do not speak French. So, moving right along here to our metric units, there's one typo I would like you to fix, and that's going to be the kilogram equaling 100 grams. That is not true. Some of you might be thinking, hey, kilo equals 1,000, and you're 100% correct. This should actually say 1,000 grams, not 100. So please, please, please make sure that you have 1,000 grams written equal to that 1 kilogram. Our 1 gram then is going to be equal to 1,000 milligrams. The vast majority of the time, we're either using kilograms, grams, or milligrams. Those are the 3 most common types of measurements, so those are the ones I want you to know the most about. Moving over to our which is larger, we can look at, okay, 1 kilogram or 1,500 grams. Okay, well, if we're doing that here, our 1 kilogram, we just said, is equal to 1,000 grams, so that means 1,500 is greater, so we're going to have 1,500 grams. All right, moving on to letter B, 1,500 milligrams or 1 gram is going to be, well, we said 1 gram is 1,000 milligrams, which means that 1,200 milligrams is going to be larger. If we look at 12 milligrams or 12 kilograms, we have the same number, so now we've got to pay attention to that unit, and kilograms is a far greater unit, so that's going to be way, way bigger. And now if we look at 4 kilograms or 4,500 grams, well, 4 kilograms would be the same as 4,000 grams if for every kilogram we have 1,000, which means 4,500 grams would be a little bit bigger, actually about 4.5 kilograms. And then if you hadn't noticed yet already, when I mentioned that cylinder, that's actually up here in the corner. That kilogram prototype, this is what it looks like. It's just this giant, or not giant, this silver, it's a large cylinder, silver cylinder that has that exact measurement of a kilogram. Of course, now we have digital measurements of this, so it's more of just kind of for nostalgic sake, in the sense that this is how that original kilogram came about, as we have those digital records of what a kilogram is. Also, make sure then you have all of this information in your notes, as it's all going to be information that's going to be really helpful for you when you practice this, or just information to know as you move forward with the metric system. I realize there's a lot of information to write down. You can absolutely shorten it, especially the piece about the standard, but make sure you definitely have those metric units and what's the SI unit, all of that information, but you can absolutely abbreviate things. All right, so now measuring mass. So now let's add a new title, measuring mass. And we use the triple beam balance here. Let's highlight that. Oop, I have the wrong color. Let's get the right color on there. We use the triple beam balance to find the mass of objects. The objects are placed on the scale, which is a metal tray. You then move the sliders, which I'll have a picture in just a second to show you, on the beams until you get the lines on each side to match up. Once you have balanced the scale, so there's 2 white lines that are even with each other, you add up the numbers that each slider is resting on. All right, so let's look at what this might be like. So looking at our example, here's our triple beam balance, and we have, so those white lines I mentioned, they're right here, and you kind of see that these are, more or less balanced. They're actually not perfect, but pretty close here, where these white lines should be on the same level if the scale is balanced. So say we had an item here, we'd then see, okay, are these things balanced? If they are, then we'd read the numbers on here. Okay, so let's do an example. We kind of have a zoomed in version here of our scale. So these are our sliders. There's 3 different sizes of them. all of them representing some amount of grams. All right, so this one, so once we have so looking at this, once you have balanced the scale, you add up the amounts of each beam to find the total masses. What would the mass of the object measured in the picture? Well, what would be the mass? I'm sorry. Now we don't know what the object is, but we can see these different numbers. So if we look on this first one, I like to just go 1, 2, 3. For the record, if you hadn't figured it out yet, that's why we call it a triple beam balance. There's 3 beams that we have. So you can see here we have the number 70, and then so that means in our first spot we're going to have 70. Okay, and then that's going to be 70 grams plus, and we have to identify. All right, so there is our 70, and then here we have 300, so it's going to be 300 grams. And then our last one, if we're looking, so we for sure have our 3, but now we have these smaller pieces. All right, and those are going to be our next, step of size of grams here. And so if we go 3, we're then going to have, okay, 1, 2, 3. All right, so it's kind of hard to, it gets a little pixelated, but it's a little bit closer to 3 here. So we're going to call this 3.3 grams. If you then add them all up, we're going to get 373.3 and then grams, right? We really want to make sure we have that unit on our end. When we're adding them up in the middle, with these 3 numbers, it's good to have units, so then if you get distracted or you forget, you're like, shoot, what was this number from? It's a better, it's easier to figure out what it was, but you really want to make sure you always have these units on our final answer, as we kind of discussed in class. All right, so now we get to summarize our notes as usual. Keep in mind these kind of the purpose from the beginning, our goals. We wanted to know the SI unit for measuring mass, and we wanted to know how to find the mass of an object using a triple beam balance. So keep those in mind as you write that summary, and then make sure you box your summary when you are done. Thanks for watching. All right, so here's a sample of how your notes should look like when you are finished. They don't have to look the exact same, but they should be comparable. Here's what I have on my first page for our notes. And here's what I have for the second page of notes. Again, make sure you have that summary. So feel free to look at these, make sure you have all that correct information. And once you're done with your notes here, then you may begin your lesson on practicing measuring mass. This video was cited adapted from the following citation on the top of this page. Some of the material is not my original content. Some of it is. It is adapted from this above site at sciencebot.net. Thank you.